We're now going to implement something with lifetimes. We're going to see what Rust does when we do that. We've seen we've done it in just in our struct before. We did that in the last video and the video before. So imagine that we were making some sort of adventurer struct, and you can see this is going to create an error because Rust is going to say, what's going on with this name? How long is it going to live? And it's going to say, please give it a name, and say struct adventurer. It has something to do with some sort of lifetime. So we say, okay, inside struct adventurer, it lives as long as A, and this thing name that we give it will also live as long as the struct, and now it's rusted happy. So the next thing we're going to do is let's implement it. So let's give it a function. So let's say take damage, and then we're going to have a mute self, and then what are we going to do? Let's self.hitpoints. Actually, let's make this an I32 because we don't want it to be go into. It should be able to go into negative hit points. Most games have that, negative hit points. So let's say self.hitpoints minus equals 20, and then we'll say print line, so-and-so has something hit points left. And we've got self.name and self.hit points. And then, okay, let's see what Rust thinks of that. And it's going to complain again. And this time it's kind of interesting. Implicit elided lifetime not allowed here. This means, so implicit means is already known, and elided means not written. So it means you're not allowed to assume that I know that how long this thing is going to live for. But interestingly enough, it can figure it out. There are two ways to do it. You can actually say implement adventure. Now, by the way, I just want to show you. This is not going to work if you just say, adventure has a lifetime of A. It's going to say this is undeclared, and that's kind of interesting because it's in this impl, this is where you say an impl block can have a whole bunch of things. It can have functions with lifetimes. It can have so you could have, say, like impl A, B, C, and there's going to be an A lifetime, a B lifetime, a C lifetime in here in all these functions. And so that's why you have one here and you have one here. So you say inside the implementation block is a whole bunch of lifetimes. Usually you don't need to do that, but for example, and so you say, and then down here in your functions, you might have something with a B in it or a C. But anyway, for this one, we only have the one, and so we're saying inside this block is a lifetime called A, so we declare it, and adventurer is the thing that has a lifetime of A, and so we can figure that out. So that's fine, but let's go back to the error message that it gave us, and it's this thing, and this is what you see a lot in Rust's source code. If you go into here, just some random part of the standard library, and you do a search for this, you can see there's 25 of them, and they're doing it everywhere. Impl blah 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 for chars, formatter. So this is a light what's it called, anonymous. So it's actually a lifetime, but Rust can figure it out. So you can say, we have this adventure thing, and we're just going to declare this anonymously here. Rust can figure it out. So this is the same way as saying A and then A over here, except for we're not giving a name. Rust can do it for us, and you can also see. Let's say you have a adventure has a last name. And for some reason, we want this to live for a different lifetime. Who knows why? So we have this, this lives for a lifetime of A, this lives for a lifetime of B. And so in our struct, we have to say inside our struct, these two lifetimes, this one's got one, this one's got another. And then it's going to say, well, I expected two. And so does this work? And yes, it does. So you see this a lot too. So you know, it looks funny, but it's just saying you could we declared them elsewhere, and Rust is going to figure it out. So so that you know, don't be afraid of that. That's all it means. And then one thing, the next thing we're going to do is declare, let's say we'll give it a display trait. And I'm just going to copy this in because we do that a lot for the display trait. And so we want to you know, have our adventure, you know, print out the hit points. We want to just be able to you know, write that and you know, the adventure. And then it should say so-and-so has, you know, so many hit points. And you can see over here as well, right there, you have, so inside here is a formatter, and this is just brought in, and it's also saying this has an anonymous lifetime. But also when we try to run this, it's going to say, well, how long does adventure live for? And once again, here we can, you know, we can do that, and then we can do that, and that should work. But you know, the easiest way to do it is just to indicate the anonymous lifetime. So you just put this little thing there, and then Rust can figure it out. So here the key takeaway is that you know, the first one was that, you know, putting an A inside your struct will sometimes make Rust happy. And the next one is inside implementation blocks, and you know, when you're implementing traits, Rust can figure things out quite well. So you can just put this anonymous lifetime after, and that is why you see this quite a bit.